learning. He works as a library student assistant in the Content and Discovery Library Systems Division in Schaefer Library. All right, I'm going to stop my share now. And whenever y'all are ready, please feel free to get started.
All right. So thank you for that introduction. I'm Corinne Chatnik, like we said, the Digital Collections and Preservation Librarian at Union College, and my job title may have given it away, but I want to preface this presentation with the caveat that I am not a collection management librarian and normally do not work in this area of librarianship. But through a student summer project that Mukundan was a part of and that I will very briefly get into, the issue of space planning was brought to our attention and an idea for automating the calculation of space allocation emerged, and my colleagues in collection management encourage us to pursue it. So, but first I want to go over some context for our library configuration. Union College is a small undergraduate liberal arts college in upstate New York. We were established in 1795, so as you can imagine, we've amassed a lot of books. We have one library building and a small off-site warehouse that we share with other departments on campus. Schaefer Library has one collection development librarian and one stacks manager, and they work together to plan for the management, purchasing, and weeding of physical materials in the collection, among other vital responsibilities. Went the wrong way. So since 2018, we have Alma and Primo as our library management and discovery system. Alma Analytics is where our input data originates from for this project. Our collection and stacks are organized using the Library of Congress classification system. For those who don't know, the Library of Congress classification system is an alphanumeric subject-based hierarchical method used primarily by academic and large libraries to organize books and materials on the shelves. It was developed in the late 19th century and categorizes knowledge into 21 major classes represented by letters like Q for science, H for social sciences. Within those 21 major classes, they're further divided into subclasses that are more detailed and descriptive. I noted the age of the classification system because many categories do not expand in content at the rate they did at its inception. So that's something we're keeping in mind for this project. We also utilize the OCLC WorldCat API for any additional information about a record that, for whatever reason, didn't make it into Alma. I will say most of our data from Alma is excellent and complete, but we have found that we are missing data from some very old records that were weeded anyway. I also want to show our stacks layout. So you'll see that our stacks are divided onto two floors, the basement and second floor. A through D in the LC classification system begins on the second floor of the library, and then the rest of the collection is housed in the basement. You'll see how an exponential growth in books in one section would throw off the layout of the stacks. Most books fall into the configuration unless the book is measured to be oversized. Think like an art and architecture book. Those books are in a separate section on the second floor. And the other one thing I wanted to highlight about these maps was that these are from the student project that I mentioned earlier. So this project was over last summer that a team of Union students created a wayfinding kiosk that we installed at the entrance to our library. On the kiosk, we have maps of all 4 floors of our library, and each point is searchable and clickable. And we'll show you how to get there via a dotted line. And so this is relevant because they labeled the stacks with the LC classification letter when we were getting feedback that it was hard to find books in our library. And so you can navigate to each area based on classification. But when we presented it to the rest of the library, the students were given constructive feedback that it was possible that those classification locations could change based on space needs. So that let us wonder if we could predict those changes to stay up to date with the kiosk. So we inquired how collection management folks know they're running out of space and how they plan for it. So the current workflow is for the stacks manager to annually physically measure the stacks and record where available space is growing and shrinking. This method is super comprehensive and precise, but very, very time consuming, especially with all the other responsibilities of the job. So we thought there must be another way. There were a couple iterations of the idea to the point that the working title of this project was and secretly still is the Wild Idea Project. Luckily, my colleagues in collection development humored us and let us pick their brains and try some theories out. So some of those theories where we tried querying the OCLC API to see if we could get dimensions of every book in the stacks and then run a calculation against the size of the shelves. But apparently we only record the height of books, which is a problem. And then another thought we had was if we could average the thickness of a page of a book and multiply it by each book's number of pages, not only did we get stumped on how to know the width of the book cover, but apparently then we were informed that different editions have different page numbers and everything. We were also gently encouraged to just abandon this idea in general. So after a lot of testing and theorizing like that, we settled on a more reasonable solution, which was to use the purchasing and weeding data, get their subclassification, and use that for an overarching analysis. So.
Quickly to introduce myself, I'm Mukundan and I'm a union student and I'm majoring in computer science and mathematics. And I work in content and digital library systems as a student assistant. And for this particular project, the general workflow that we followed was broken into three different parts. First part was actually collecting the data, and then the second part was processing it, and then finally visualizing it. So for the first part, which was the data collection, we pulled an analytics report from Alma in an Excel spreadsheet. The spreadsheet would have a list of all the works and the corresponding information about each particular work, like the work name, the LC classification, or what if the classification was actually unknown, it would at least have an OCLC number. And this data was pulled twice from Alma, once for the acquisitions or the purchases that were made, the works that were bought, and once for the weeding data. And the next stage in the pipeline was actually processing the Alma exported data. And here the overall goal was to count the number of works we bought or weeded in each LC subclass. So first we made a reference text file that essentially had each LC subclass ID, like AC is an LC subclass ID, mapped to the actual subclass name. We then went through the Excel spreadsheet and looked at each work's LC classification, the year it was either bought or weeded, and in order to aggregate a count per subclass for each year. However, for some of the works, the LC start range was unknown. So, which is where we needed to use the OCLC numbers to obtain the LC classification. To do this, we used the WorldCat metadata API to send OCLC numbers and receive LC start ranges, which we then used to map the work to the right class, right subclass for the right year. So one thing about the Alma exported data was that it only had either purchase data or weeded data. So we needed to process the data twice, once for the purchase spreadsheet and once for the weeded spreadsheet, and then classify the works based on the subclass. And when we were looking at each work, we factored in that regular works are different from oversized works, since they're, in terms of LC classification, there's an LC class A for regular works and an LC class A for oversized works. And to account for this, we did the counting twice, once for regular stacks and once for oversized stacks. And we also excluded works like periodicals, DVDs, and other types of media, since they didn't belong in the library stacks, but were actually placed in different locations inside the library. We saved the processed data to JSON files, which is basically another way to store data like text files. So basically, like on the right on this slide, we would have a subclass ID, like QC, storing some information about itself, like the subclass name, which is physics in this instance. And it would also have a yearly count, which would show the number of books that were either purchased or weeded for every year we examine. You'll see there's a negative number for 2025, which we'll get to in a minute. And so we stored this type of processed data for purchased works and weeded works separately. And then finally, we integrated the data to make a net change data table. The idea for this net change was that essentially, if we took the number of books that we bought in a subclass for a given year and then subtracted the number of books that we weeded in that subclass in that particular year, then we could see the net change in the number of books for that subclass on our library stacks. This data on the right here is part of that integrated data. And to interpret it, how to interpret it is we see that the collection in the QC subclass increased by 45 books in 2022, 28 books in 2023, 34 books in 2024, but it decreased by 13 books in 2025, and it didn't change yet in 2026. So the next stage of the project after processing the data was actually visualizing the data, since a file of numbers can only be so useful to see patterns. So we took the processed data and made bar graphs for each individual LC class. So the idea was that we would have a bar graph, like on the right here, for each LC class with individual segments of bars representing each subclass. The vertical axis would have the net change of books in the collection. You can see that it can be either positive or negative. And the horizontal axis has the years that we are looking at. To avoid seeing insignificant changes in the collection, we put the threshold for being on the graph to at least 5 books purchased or weeded in a single year. And this limited the number of subclasses that we could see on the graph to only the significant ones. And overall, this made quite nice visuals where we could see nice patterns. In this graph on the right, which is for the science LC class, we see the breakdown of how many books were bought in each subclass. For example, QA saw a lot of books coming in 2022, but QH has kind of held a steady growth rate over the years. And looking at it even more high level, we see that the QLC class as a whole has seen more growth than weeding over the past couple of years, which makes us question on whether there is enough room in the stacks to actually keep adding at the same rate. Maybe we should shift our attention to weeding a part of the collection that we aren't using. And these are the types of questions and insights that we think this project can help us see to help with future space planning. And these are a couple of other graphs that were made from the processed data. And the one on the left is a sole purchase plot, which is only based on the purchased data. And it is for the HLC class. And the one on the right is for weeding only for the PLC class. And kind of looking at these plots would help to see trends on where there's a lot of material coming in, which classes, which LC subclasses where there's a lot of material coming in, and where there's a lot, or actually not a lot, going out. And we were looking at graphs for every single LC class with subclass information for each LC class. So naturally, we were curious on what would happen if we took a step even higher up and asked the question on how does each LC class itself look over the years as a whole. This allowed for the creation of all LC class graphs, like the one on the left, which has bars that represent growth or shrinking in the entire collection with bar segments for each LC class. Note that it's a class like A, B, C, D, and it's not a subclass anymore. This type of a graph allows us to see how we're doing with the net change in our overall collection itself without getting too detailed with subclass information. And it could be a good starting point to get an overall grasp of how we're doing in terms of purchasing and net growth, and if we should choose a particular subclass or class or classes that we should weed in.
So the analysis of this has allowed us to have broad discussions about trends in purchasing and weeding. It gives us a bird's eye view to the potential space pain points that we might encounter in the future. The visualizations show that in some sections we are buying more than we are reading, which is helping the collection development librarian and stacks manager to figure out where to focus future reading projects. It also shows that in other sections we are not buying new material at all, and we don't have time, and we don't have to leave as much space for those sections because they aren't growing anytime soon. It's also an interesting analysis of buying patterns that can be sourced back to curriculum additions and changes over the last few years. And we've only been working with this output for a few weeks though, but we have been encouraged in our efforts and have plans to improve and make the tool more user-friendly.
So in terms of future work, we definitely want to see if we can programmatically identify hotspots in the data. So where is material coming in the fastest? Does it correspond to a class where we barely weed? Is there a collection that is being weeded significantly and making more space available? So we want to try to automatically answer these questions with code, if possible, as one of our next steps. The ideal goal would be to make an interactive analytics dashboard that displays important trends and allows staff to see movement across the stacks visually as best as possible. The dashboard could also be a place where they can run reports and get graphs for subclasses they want to see for specific years. And going even farther, a higher ideal goal would be to make predictive models for each LC class and see how it will either grow or shrink, and also integrate the physical amount of space that we have on the actual shelves with these visualizations for thorough and weighted analysis. And so these are some of our future goals with this project.
Thank you. Any questions?
Mhm.
All right. Well, thank you very much for that. That was really fantastic. I really enjoyed seeing what y'all are up to with that project. We do have a couple questions, and I'm going to ask those questions to you now. If anyone has any additional questions, please use the Q&A button to put them there. Our first question is, many of our call numbers have the wrong first indicator in the 852 field of the holdings record in Alma. That makes it difficult to trust that something marked as LC or Dewey really belongs to that classification scheme. How did you account for that?
Um, I think we trusted our data. And like we said, when we weren't sure or didn't have it, we queried the OCLC API.
All right, thank you. Our next question is, are the Alma Analytics reports available in Union's shared folders for the community?
Like the ones we generated or
Yeah, I'm assuming that, but feel free to clear that up in the chat then.
not yet. We're still, so we've been meeting with the collection management team and kind of getting feedback on what kinds of data and visualizations we're getting, and then sharing what we have, and then going back and making more edits. So I don't think we're totally at a point where we're ready to make them the final draft.
Okay. Um, you are predicting future growth based on past growth, correct?
So, kind of. So right now where the project is standing is that we have kind of a data visualization for the past years, and we haven't really looked into how to predict these types of models yet. But due to the fact that we only have perhaps 7 to 8 years of data, which is very little for to create predictive models. But we would be looking perhaps at hotspots in the data more than actually predicting and seeing where we can focus our attention most.
Okay. Next question. Could you share your JSON schema and your Alma analytics analysis?
I think this question is asking about how the JSON data is organized, I believe. So the data is organized where JSON is essentially a file where you store key value pairs. So the keys would be the subclass IDs like A, B, AC. These would be the subclass keys. And the values would be the subclass name and a dictionary that would have a yearly count. So, like the one we saw on the graph, 2022, 2023, 2024, the years would each have a different number of counts for books read or purchased. And the Alma analytics analysis was basically we used Pandas for Pandas library to go through the Excel spreadsheet and process the data that we pulled from Alma.
Yeah, I think also they might be wondering if we'll ever post it on GitHub or something.
Yeah, so right now the project is local on my machine, but definitely when we're thinking about putting it on a GitHub, the Schaefer Library GitHub, something like that, so that it can be used for different purposes.
All right, thank you. Our next question is, did you account for donations at all?
No.
All right, thank you. We have another question. Have you thought about integrating circulation statistics with the ad/weed data?
Yeah, actually we have. I don't know, Mukundan, do you want to talk about it? But we're working on figuring out what data points in Alma Primo that would help us with the circulation points. But it is one of our future plans.
Yeah, so I don't think that data came in with the Alma exported data that we were using. So that was definitely something that we are discussing currently as like kind of a next iteration.
Okay, next question. Are there any plans to analyze circulation? Oh, was this just the question? Sorry. Well, if it is, then you can answer again or just pass. Are there any plans to analyze circulation statistics with this project as well?
Yeah, I think that was the answer we just
All
gave.
right. Sorry about that. My attention was elsewhere, so it looks like I asked the same question from two different people. Okay. Another question. I think the subtitle of the presentation mentioned Python use, but the presentation didn't really expand on that part. Was it used primarily for the API requests and JSON transformation, or anything else as well?
So yeah, the kind of this project is entirely written in Python. So from taking the data in, using the Pandas Python library to convert the data to a data frame and analyze the data, go through it, and aggregate the number of books per subclass, and then save that to JSON. All of it is written in Python. And then after saving it to JSON, taking that JSON data and making visualizations we did with a Python library named matplotlib. So kind of the entire project is written in Python.
Okay. The next question. This is a great presentation with a student assistant in a computer science program. Could you share how we may establish more interest with computer science department to attract students to work and have access to interesting work at the library? And I agree, this was a really great collaboration.
So it kind of happened by accident. We did the summer fellowship last year with the kiosk, and Mukundan was one of the team members. And I really liked his work ethic and his creative thinking, and so I hired him for his work study in the fall. Um, and then we stumbled on this problem.
All right, great. Thank you. Our next question. Did you try the graphs with one class or subclass with the sections based on year? If you did, what did that look like? Was it helpful?
Sections based on year. So I think our graphs right now have individual LC classes like A, B, C, with subclasses being like individual parts of one graph, and where the x-axis is the year. Here the question seems to be asking, what if about the sections based on year? I don't
I
think
think
we
we,
tried this exact model.
I think we might have done it when it was still a line graph. It was like the growth over the whole year, maybe, or I'm not sure.
Hmm.
No, I don't remember either.
Yeah.
All right, thank you. Our next question. Was this only physical items or did you also include electronic items?
Only physical.
All right, thank you. Regarding future work, have you considered methods of incorporating purchasing and or budget information in your analytics dashboard?
Oh, okay. So, uh, definitely incorporating purchasing information since, purchasing and weeding is an ongoing process and we want to be able to kind of push a Alma exported data into the script in the future and get out graphs ideally. And I don't really know about budget information.
Yeah, I don't think we've talked about that, but that's an interesting idea.
Okay. Next question. I have always used 1.25 as the average size of books, so if I have 12.5 of space, I have room for 10 books. I just wanted to share that in case it's helpful. Thank you.
It is. I think we found like we tried all sorts of things. So we found like a book with calculator and I don't even know. But yeah, I think we liked when we settled on the sub classifications, it seemed to make the most sense for the most amount of people in the library. Um, and was more interesting to it gave more interesting visuals to analyze.
Okay. Oh, this is an interesting comment left. Harvard did create a calculator for page number to linear inches for a moving project, and that link was shared. I'm gonna copy and paste that in the chat now too. So thank you for sharing that. That's interesting.
Thank you.
Next question. Were there other restrictions that caused you to move on from that idea? Oh, I'm not sure if that's in regard to a follow-up to another question, but
Mm.
feel free to expand upon that in the chat.
I think it was more of a the juice wasn't worth the squeeze kind of situation where we were going way too far in the weeds when going section by section was a lot more manageable.
Mm, that makes sense. Thank you. And our final question, although we do have 2 more minutes left, so if someone wants to ask one more, feel free to drop it. But though this was for predicting physical space usage, do you think this framework could be used to analyze ebook collections and seeing which LC classes are either growing or shrinking?
Yeah, completely. If we have the data, we can definitely push it in and see, map the ebooks to LC class, see which LC classes are growing and shrinking. One of the next steps of this particular project, I would say, is integrating the actual physical space that we have on the stacks. And this would not, of course, for an ebook, this wouldn't apply, but this type of a project could definitely apply for ebooks as well.
All right, great. Thank you. That just about brings us to time. So I would like to thank you two again so much for this presentation. It was just really cool, really great project, and just it's just really great. Everyone in the chat is echoing that. Everyone thinks that, a really awesome project, awesome collaboration. Mukundan, everyone really enjoyed your presenting. So just, excellent collaboration, and we all really enjoyed it. So thank you very much, both of you. We really appreciate having you here. And
Mhm.
with that, we're gonna move to our final presentation of the day. I'm gonna now pull up my little introduction card. Bear with me one moment, please.